So in this question, a ball which falls from a rest through the air towards the ground. The diagram shows the two forces acting on the ball. So as you can see, as it is falling, this object, as the air resistance is acting, air resistance start to increase. So what happened to resultant force? That will decrease. So if we plot a speed time graph for falling object with air resistance, in the beginning, it has a constant acceleration. Then acceleration start to decrease and eventually the acceleration is zero, or it will move at a constant speed, or it does not change the speed. When it does not change the speed, we can say the weight, the gravitational force, and the air resistance are equal to each other. So as a ball falls, the air resistance increases. So air resistance increase, what happened to the resultant force? The resultant force will decrease. Why? Because air resistance try to resist the motion. It's opposite to direction of motion. That's why the resultant force is decreasing. And if the resultant force decrease, what happened to acceleration? It will always decrease if the resultant force is decreasing. So option B can never be an answer for any falling object, because acceleration of falling object can never increase. Either it is constant or it will decrease. So that's why option A is the right answer, that the acceleration of a ball is decreasing. Why C is not correct? The speed of the ball decreases. As you can clearly see, the speed is not decreasing, speed is increasing. Speed will only decrease if this ball or this object will use a parachute. Without parachute, speed will initially it will increase and then it will be constant. The change in the speed is decreasing and until or eventually the speed is not changing. But there is no decrease in the speed. And the gravitational force is decreasing. That's also wrong, because as it is moving towards the earth, either we consider gravity to be constant or it will increase towards the earth. So whenever falling objects are there, if I say speed, the first example, when we drop from certain height, it was 0 meter per second. Then after 1 second, it is 10 meter per second. Then after 2 seconds, 20 meter per second. Now as the air resistance start to increase, it will try to resist the motion. So it will try to change the acceleration. Yeah, why C cannot be an answer for why we cannot say the speed is decreasing. This cannot be a valid answer. What is the reason for that? When we drop an object, like this object is dropped. So when we drop an object, initially it is having 0 meter per second. Then what happened? As it fall, it will have an acceleration which is due to gravity about 9.8 or 10 meter per second square. So speed will change by 10. The weight is acting downward. Here also weight is acting. But as the speed start to increase, the air resistance will also increase. So air resistance try to resist the motion. So here air resistance is less than the weight. So still it will accelerate, but it will have a smaller acceleration. Like first it was 10, but now maybe now the acceleration may be 5. So acceleration is decreasing. And eventually the weight and air resistance are balanced with each other. So when weight and air resistance are balanced with each other, it will not change the speed. It will continue to move with the same speed. So speed and time graph for object without air resistance or with air resistance, first it will have a constant acceleration, then acceleration decreases, and eventually there is no acceleration or a constant speed. So you can see the speed is increasing or speed is constant here. Speed is not decreasing, acceleration is decreasing.